My name is Julia Berdecia, presenting my final integration project, Single Cycle CPU, for computer organization taught by Professor Gertner. The objective is to design a single cycle CPU utilizing MIPS architecture to program the following instructions into the arithmetic logic unit, utilize LPM modules for instruction and data memory, to implement a CPU controller for instruction opcode signals, and the real test to create a test bench that reads 6 numbers from data memory and computes their sum in memory. This is what the single cycle CPU data path will look like. Before we get to the code, here are truth tables for the CPU control unit for I-type and R-type instructions. The CPU control unit essentially takes in the opcode and function code from the instruction, and based off of this, it will modify control signals shown in the truth table. For this project, we needed a multiplexer, program counter, sign extender, instruction memory, data memory, of course a register file, the arithmetic logic unit that takes in the ALU control signal signifying which operation should be performed, the ALU controller which contains case statements which perform the operations shown, a package for the single cycle CPU containing all component declarations in one place. Utilizing these declarations is the single cycle data path file. This is essentially a translation of the diagram shown early in the presentation. Next, all the signals declared by the CPU are going to be the inputs and outputs of the components. The test bench I created includes machine instructions to read 6 numbers from data memory and compute their sum to store the result in memory. It also includes a multiplication and branch equal instruction. Here's the simulation of the single cycle CPU. Here we have a simulation of the addition created with a loop in the test bench. Just for fun, here's a simulation for the multiplication, also created with a loop in the test bench. And lastly is a branch equal instruction in the simulation. In creating a single cycle CPU, several components used from previous labs were utilized, culminating to this result with all that we learned. In general, I gained knowledge of design, verification, and simulation of various computer blocks in this course. I'd like to thank Professor Gertner for a wonderful semester.